In this example, we will calculate the electric field from the uniformly charged distributed on an infinitely large plane. Okay. If we have an infinitely large plane, like this, and we want to calculate the electric field at this point at a distance h above the plane. First, assume that the charge on the plane is positive. And the surface charge density surface charge density is sigma. Okay. To calculate the electric field in this case, we can also use the Gauss law. But before we do that, we have to find the symmetry of this problem. In this problem, you can see that we must have the symmetry, that is, if we look at any point with the same height as the point that we are interested. Okay. We should have the same magnitude of electric field, right? Because if we use the symmetry, if we are here at this point and we look back to the chart, to the plane, and if we are at this point and we look back or look down at the plane, we must see the same charge. Okay, we must see the same charge. So there is no reason to expect that the electric field here and here have a different value. So we can, from the symmetry, we have that first. The magnitude of electric field is has the same value at the height h above the plane. Okay, this means that if you look at the point, any point that is at the distance h above the plane, the magnitude of the electric field should be the same. Okay, so that is the first uh, is a result of the symmetry. We should also have that the electric field point perpendicular to the plane. Okay. This is the same reason that we used in the previous example. That is, if we look at the electric field from this point in this direction and from this point in this direction, if the electric field does not point upward perpendicular to the plane like this, we will see the different electric field if we look from this point and if we look from this point. But that should not be the case because the symmetry, when we are here and we are here, we must see the same picture of the charge. So it's no reason that we will see the different electric field. So we should expect that the electric field point upward. If the charge is positive, it will point away upward, perpendicular to the plane. But if the charge is negative, it will point downward to the plane, but in the perpendicular direction to the plane. Okay, so we have second E. The electric field is perpendicular to the plane. Okay. From these results, now we can construct the Gaussian surface. The shape of a Gaussian surface can be arbitrary except one condition, that it must have the surface that parallel to this plane and the surface that perpendicular to this plane. For example, I may construct the Gaussian surface is like a cylindrical Gaussian surface that passes through this plate or this plane, and the top and bottom surface is parallel to the plane. Okay, the top surface of the Gaussian surface and the bottom surface parallel to the plane, and the curved side is perpendicular to the plane. Okay, and also we construct the distance from the plane to the top surface and to the bottom surface. And the same, which is h. Okay, this means that if we look at the bottom surface, we will also have that the electric field point perpendicular to the plane like this also. Okay, this surface should contain the point that we are interested on the top or maybe on the bottom. No problem. Okay, in this case, I construct the surface that have the point that we are interested to find the electric field on the top surface. From the Gaussian surface like this, you can see that we will have that on the top surface, the electric field will parallel to the vector dA. But in the curved surface, like this, we will have that the electric field is perpendicular to the vector dA on the curved surface. But on the top and at the bottom, we will have that E is parallel to the dA. So it means that and top and bottom surface, we have that E dot dA is equal to E dA. While at the curved surface, we have that E dot dA is equal to 0, right? Because here we have that these two vectors is perpendicular. Okay, here. Now we can use the Gauss law. We can say that the total flux on this Gaussian surface is equal to the integral over the closed surface of E dot dA, which we can say that it is the integral of E dot dA on the top surface plus the integral of E dot dA at the bottom surface plus integral of E dot dA at the curved surface. But we know that E dot dA equal to 0 at the curved surface, so we have that this term is 0. Also, since the top and the bottom surface are at the same distance from the plane, so we should expect that these two terms is equal, right? Because the area here at the bottom and at the top are the same. So this integration should give us the same result. It means that we can say that the flux is equal to 2 of integral from E dot dA at the top. Okay. Now the integral of E dot dA at the top is equal to the integral of E dA at the top surface. But from symmetry, we also have that E is a constant on the top surface. So we can take E out of the integration. So this is E integral dA at the top surface. And E dot dA at the top surface is the area of the top surface. Equal to EA, where A is the area of the top surface, which equal to the area at the bottom surface. So we must have that this flux is equal to the 2EA, which is from the Gauss law is equal to Q over epsilon 0. This Q is the charge inside the Gaussian surface, which in this case is the charge on the plane inside the Gaussian surface, this means here. And the charge here is in the area of A, right? Where A is the area of the top surface. Okay. So here Q is equal to the sigma A, since sigma is the surface charge density. So on this area we must have the charge equal to the surface charge density times the area, and this equal to 2EA. You can see that A cancel in this expression, so we have that E is equal to sigma over 2 epsilon 0. Okay, this is the magnitude of the electric field, and the electric field point away or toward the plane in the perpendicular direction to the plane. Okay, it is interesting that E is not depend on H, so it means that